Hello everyone, today we're gonna play around with integral calculus and we're gonna solve some calculus problems together. These are not the easiest questions. I personally am gonna open up and be a bit more vulnerable and tell you that I have failed some of these questions. I didn't find a solution on my first 2 or 3 attempts, so I hope you learned something from this video. Alright, the first question is, evaluate the integral of this natural log of x over x squared dx. Well, here we need to use the reverse product rule. Oh, why is it so fat? Give me a second. Gosh, I don't know which one to choose. That's not the reverse. From differential calculus, we know that f of x times d of x, I mean the derivative of it, right? The derivative of the product of two functions is equal to the derivative of the first function times just the second function plus just the first function times the derivative of the second function. We can use exactly this same principle, if you will, to find an answer to this question that we stumbled across. So we know that the integral is just an antiderivative of a certain function. So if we have 2 of x, then the antiderivative of it is going to be 2 squared plus x. Or more generally, we can say the integral of f of x times d of x is just capital F of x, where this signifies the inverse function. I'm not going to dive into the inverse functions, otherwise this video is going to be too long, but the basic concept behind it is if you have two functions that are inverses of each other, then if you give the original function the value of, I don't know, like 2, for instance, then you're going to get a certain value in here, and this 2 will go back to your original function. Those are the inverses. If you forgot them a bit, just look them up on the internet. There are many videos about them. Anyway, we're getting back. The reverse product rule. How can we use the reverse product rule to find an answer to this integral? Well, it's quite simple, really. Imagine we have the product of two functions. And we know that the derivative of this product will get us here. But we also know that the integral of the derivative is going to get just the function itself. So we can say that the derivative, the integral of f prime of x times g of x dx plus the integral of f of x times g prime of x dx will get us back in here. And it works because the integrals here are the inverses of the product of two functions. Well, now we can use it for our own advantage. We can just rearrange this notation quite a bit. We can say f prime of x times g of x dx is equal to f of x times g of x minus the integral of f of x g prime of x d of x. And you might ask, how does it even apply to our original question? Well, we can quite literally visualize that this part is going to be this part. And then we can get the rest by just following the same logic. So we have the integral of the natural log of x over x squared times dx. All right. So our goal here is to choose one of these as being our derivatives of original functions and choose another function that will be easy to take the derivative of in this part of the equation. Well, what is much easier here to do? I think we can say the natural log of x, and then here, if you're taking the derivative of a certain function and then you get x squared, what should that original function be? For example, you can take the derivative of x squared and you're going to get a 2x. What should be the function if you take the derivative of, you get x squared? Well, it should be x cubed over 3, right? Because the power rule tells us that you get the 3 here, and then it gets simplified. And then you have this increment by 1 rule and x squared. You know all of that. So the answer is going to be x cubed over 3. And here we write exactly that. And the second part is going to be pretty simple. We have an integral of f of x. Remember, f of x is this part. We took the derivative of it, and then we got here. Oh, actually, my apologies. It's not going to be x cubed over 3, because here it is x to the negative 2 power, right? Not just x squared, because it's in the denominator. So we would need x minus 1, then minus 1 here. That should be our function. So I'm really sorry, we're gonna get this at the very end. I just rewrote the same thing here. I distributed the negative sign to the front, and then we have the function itself here. Okay, let's just get rid of all this mess that I made. So here we have the function that we took the derivative of, we got here, and then we have just the function itself. So to fulfill this part of the equation, we would need just the first function, meaning negative 1 of x, times the derivative of the second function. And the derivative of ln of x is going to be just 1 over x, right? Dx. So we're solving for this part. We're going to leave it there. Negative ln of 1 over x minus the integral of negative 1 over x squared. Then we can quickly simplify this. Oh, I got no more space. We have to be a bit quicker. ln x. Then we can write it as x to the negative 2 power and then what should be the antiderivative of this function right over there? Well, it should be x to the negative 1, right? If you get it here, you're gonna get negative 1, and then you increment it by 1. Yep, works perfectly. So after all of this, we put plus c, which is quite important, and we get that. So what should be the answer? The answer is negative ln of x over x. Then we had, well, negative x to the negative 1 power is the same thing as negative 1 over x, and then plus c. Does this match any of the options we've got in our answer choices? Yeah, it does. Answer is D. So the way we solved this problem is we leveraged the reverse product rule, and we were able to arrive at a conclusion that we can use the power rule from the differential calculus to figure out the integral of a relatively complicated function. I mean, it doesn't look very easy, right? It's not the easiest thing you can take the integral of. Thank you for your time.